This is a practice exercise video solution.
For this practice, let's get started with the supplied dataset, simple turned part practice.f3d. We're going to navigate to the manufacturer workspace, go to turning, and set our units to inch. We're going to be creating a very simple program. We want to get started by creating a new setup. First, we need to note the orientation. Z is pointing the incorrect direction and the chuck is on the wrong side, so we're going to click on the Z to flip the orientation of the part, noting the location of the chuck. The location of the chuck is going to represent where the machine is holding onto our stock. Even though our physical part is much shorter, we do have some extra material that can extend on this side. So in order to do this, we're going to go to our stock tab and make sure that we do increase the overall length to 3 inches. When we do this, noting that it's going from the center of the part, but we want to offset it from the front. We also can add a small offset to the front so we can face the end of the part of 0.05. When we navigate back to our setup, we can now see that the chuck is located on the extension of our stock. From here, we're going to leave everything as is, moving on to our post process, and we're going to add an extra 5 to the end of our program number. We're going to have a comment of simple turned, and hit enter to say OK. The WCS of 0 will represent the next available coordinate system, and in most cases that's G54. So the next thing that we need to do is create a basic set of toolpaths to machine our part. We're going to begin by going to our turning dropdown and select turning face. We're going to select our tool, and to do this we're going to navigate to our Fusion 360 library under cutting tool inches, and we want to make sure that we are taking a look at all available tools. In this case, we need to find our turning tools. We're going to select turning tools inch and note all the available tools. The first tool that we want to select is the second tool in our list, which is a CNMT 32.52. Now this is a right-handed general purpose tool, and we're going to select it. Noting the orientation of our tool as we rotate our part around, it's coming in from the positive X direction. It's going to come in. It's going to remove the material and drag itself away, so we can simply say OK. Next, we need to create a roughing profile, so we're going to go to our turning tools and select turning profile roughing. We use the same tool, and we're going to allow it to use all the default settings and say OK. This will allow the tool to come in and make multiple passes. Last, we're going to go to turning profile finishing. Once again, we're going to use the default settings, but we want to navigate over into our passes section and make sure that we're taking an appropriate number of steps and an appropriate size step over. We're going to say OK, allowing it to create that finishing pass, noting that it's ending at this corner. If we need the tool to go further down the part, we can always modify our tool path. We can take a look at our geometry. We can move our back plane. And we can make sure that the tool does extend far enough past the part. You notice that we are getting a warning. It's telling us that the lead out has been modified because it's gouging remaining stock. And that happens when it goes past the end of our part. I'm going to allow it for this operation and move on to our turning and select turning part. We need to select a different tool for turning part. So I'll go down to our turning tools, and we want to take a look at our OD grooving tools. We're going to select this OD grooving tool, say OK, and allow it to part the remaining stock. At this point, we can also select the entire setup, go to Actions, and Simulate. When we press play, we can see it creating the turning tool paths for the entire part, and at the very end, it does remove it from the rest of our stock. Once again, note that in some cases we might see warnings for our toolpath. You'll need to evaluate whether or not those warnings are warranted and need action to remedy. In this case, it did modify our lead out parameters to prevent some additional gouging. Let's go ahead and exit the simulation and make sure that we save the part before moving on.